In this Math in Minute video, we're going to determine whether a function is even, odd, or neither. So to determine if a function is even, you can look at a graph and see if there is symmetry around the y-axis. Algebraically, you can substitute negative x wherever x is in the function, and when you solve it, if you get the original function back, then it's even. Also, you can determine it by the degree or exponent or constant. If all the exponents in the polynomial are even or constant, it is an even function. To determine if a function is odd, you can determine it if the graph is symmetrical around the origin. Also, you can substitute negative x into the function, and if the original function is negated, then it is an odd function. If all the degrees in the polynomial, the degrees or the exponents are odd, then the function is odd. A function is neither even or odd if the graph is not symmetrical around the y-axis or the origin. Also, if you substitute negative x into the function, and it doesn't come back to the original function, or the original function is not negated, then it is neither. If the polynomial has a mixture of even and odd degrees, then the function is neither even or odd. So let's take a look at these three graphs. We can see the y-axis is here, and there is symmetry around the y-axis. This side is symmetrical to this side. Again, the y-axis is here, and this side of the y-axis is symmetrical to this side. Down here, again, the y-axis and this side is symmetrical to this side. So when we have the graph has symmetry around the y-axis, across the y-axis, then the function is even. So let's take a look at these three graphs. Here I have the origin. In my first quadrant, I have this arrow going upward. If I were to take it around to this third quadrant, I would have symmetry. So this in quadrant 1 is symmetrical to this in quadrant 3 around the origin. Likewise here, we have the origin and we're in quadrant 2, and this is symmetrical to what's in quadrant 4 around the origin. Same here with this last graph. Here's the origin. We're in quadrant 1, and this is symmetrical around the origin to quadrant 3. So these graphs are symmetrical around the origin, so they are odd functions. So looking at this last set of graphs, we can see here there is symmetry around the x-axis, but that's neither the y or the origin. So this particular graph is neither even or odd. If we move over here, there is no symmetry around the y or the origin. This graph is neither odd or even. Likewise, this third graph, there is no symmetry around the y or the origin. So all of these graphs would be neither. So now let's look at the method of substituting negative x into the function. Here we have f of x equals 2x squared plus 3. If we substitute negative x in where x is, we would get 2 times negative x squared plus 3. Negative x squared would give us positive x squared. So our resulting function would be 2x squared plus 3, which is the same as our original function. So in this case, the function is even. Let's go ahead and substitute in this equation f of x equals 4x cubed minus x. So everywhere there is an x, we're substituting negative x. So 4 to the negative x cubed minus negative x results in negative 4x cubed, because Negative x times negative x times negative x gives you a negative. So that's why we have negative 4x cubed. And we're subtracting negative x. So minus a negative gives you a plus x. So if we were to take a negative 1 out of this equation, we would get negative 1, and in parentheses, we would have 4x cubed minus x. And that is the same as our original. So we are negating the original. Therefore, this function is odd. Lastly, we're going to substitute in our function 5x plus 1, negative x. So we have 5 times negative x plus 1. That would yield negative 5x plus 1, and that is not the original. If we take a negative 1 out of the equation, we would have negative on the outside of the parentheses, and within the parentheses, we would have 5x minus 1. This is not the same as our original. It doesn't negate the original. So therefore, since it does not get the original back, the original function is not back, and it's not the negation of the original, this function is neither. Lastly, let's determine whether a function is even, odd, or neither based on the exponents. We have an even exponent on this term, we have another even exponent, and we have a constant. So by definition, this equation, this function is even because each term has an even exponent or a constant. This next polynomial, we have an odd exponent, an odd exponent, an odd exponent. And this is also an odd exponent because that's like x to the 1. So if all terms in the polynomial are odd, then the function is odd. Lastly, we have the exponents. In the third equation is 3, which is odd, and the second term has an even, and the constant would be evaluated as an even. So these are mixed. So when you have mixed exponents, the function is neither even or odd. You can determine whether a function is even, odd, or neither graphically, algebraically, or by the exponents. Any math topics you would like me to cover, please leave in the comments below. Thanks for watching. Please subscribe, like, share, and we'll see you next time.